All right, let's review this chapter 3 test. The big thing on this front page, I want two things to stay in mind. Number one, there should have been no decimals needed on this front page. Number two, simplify radicals. Number three, I think the order to try to solve these things in are square roots if possible, factoring if possible, and then after factoring and only after factoring would I go to quadratic formula or complete the square. I guess it's totally preference up to you, but some of you tried to shoehorn quadratic formula on anything and maybe got confused and you didn't need to. See, the thing is, I know here in A, you don't have to, or you can't solve with square roots because there's two terms, but I do know this factors as this. So from that, I can say this is going to be x equals 2, and this is x equals 2. So it's a repeated root. You could write 2, or you could just write 2 comma 2. This one in general, B, I could really understand if you went to quadratic formula because you see that. My issue is I'm just a good factorer, so I know that this is a perfect square trinomial. And if we go minus 4, that right there will multiply out to our given problem. So then when I set this equal to 0, we get x equals 4/3, and of course it's the same parentheses, so that'll be the same thing. Again, repeated root, you could write them both, or you could just write one. All right. Now this next one, C, obviously I can't use square roots. There's more than one k term, but before I make any decision on what I'm going to do, I'm going to get it equal to 0, which involves subtracting 2k squared over, which involves subtracting 11k over, and then I get k squared minus 9k equals 0. Now from there, that's right in my wheelhouse of factoring. Right? This implies that k equals 0. This implies k equals 9. So 0 and 9. This next, all three of these problems are ones that I will be trying to use square roots on. I'll be using square roots because there's only one x term, one x term, one x term. It just seems easiest to me, guys. So if I add 8 to both sides, I get negative 8x squared equals negative 23. Get x squared equals negative 23 divided by negative 8. The negatives cancel. And then I can square root and get x equals. And a lot of you seem to forget about the plus or minus. That's my favorite answer. There are different things that could have happened, such as plus or minus root 23 over 2 root 2. Not that you know that's any better. And there were other ones from other people that I accepted. Really, if you want to check whether it's something that should have been accepted for you, figure out what the decimal for this is, and then compare it to the decimal of your answer. All right, so I'm going to continue here with method of square roots. I'm going to square root, and I'll have plus or minus root 3. Subtract the 1 over. Make sure you have that negative 1 in the right spot where it belongs. And the last one, I'll add the 30 over, and I'll get this. I'll divide by negative 2, and I'll get this. I'll square root, and I'll get this. I'll understand that I do not want a negative under the radical, so I'll know that it's the same as this. And of course, the square root of negative 1 is I. So really, we should have been plus or minus I root 15. Going down to the last one. First thing I'm going to do is multiply this into a binomial. I'm also going to subtract the 1 over. So now I'm going to mess with this thing. This might be the first time on the whole front side I'm going to use quadratic formula. So negative b plus or minus the square root of b squared minus 4ac all over 2a. And I'm going to work to simplify. So negative 6 plus or minus, let's see what that discriminant is. 6 squared minus 4 times 1 times negative 1 is 40 over 2. Now the issue is we want simplified radicals, so that's the same as square root of 4 times square root of 10 over 2, which makes it negative 6 plus or minus 2 root 10 over 2. Now the next thing you're going to have to notice is that's divisible by 2, this is divisible by 2, and this is divisible by 2. So I'm going to go ahead and divide everything out to make it this. Notice it doesn't change what's under the radical. We may need to talk about that some more with as much people as had trouble simplifying. Let's get this thing equal to 0 and see where it takes us. So we got 7t squared minus 28t minus 14 equals 0. I think it'll factor. If I take out a 7, that'll be 2, but the middle term will be 4. I don't think so. So I'm just going to go straight to quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. So 28 plus or minus. Let's see if that discriminant is negative 28 squared. 4 times 7 times 1176 divided by 14. Now I'm going to work on simplifying that radical first. I'm just going to start taking 1,176 and dividing it by the perfect squares at the front of the room. So divided by 361 now, divided by 289 now, divided by 256 now, divided by 225 now, divided by 196. Yes. So that becomes 28 plus or minus root 196 by root 6 all over 14, which means 28 plus or minus, I think 196 is 14 root 6. Now, again, there's 3 terms. You notice this is divisible by 14, this is divisible by 14, and this is. So we go 2 plus or minus root 6. All right, moving on to the last one. We'll add 12h over so that we can get it equal to 0. Again, I don't think I'm even going to bother trying to factor it, so straight into the quadratic formula. (132 over 6). Let's see, 132. I'm going to try to simplify. 132 divided by 'So if I make that negative 12 plus or minus root 4 times root 33 over 6, that can make it negative 12 plus or minus 2 root 33 over 6. Again, going to talk about that's divisible by 2, that's divisible by 2, and that's divisible by 2. So negative 6 plus or minus root 33. And then this divisible by 2 is 3. Again, on this one in particular, I had multiple right answers of people that did it different ways. That's just my base way. Okay, this is really the only two problems on the whole front side that you had to complete the square. And even then, you didn't have to do it, but I wanted you to. So we sit there and go to find that missing piece to complete the square. So 18 divided by 2 is 9. 9 squared is 81, which means we also have to add 81 over here, which makes it y minus 19 equals x plus 9 quantity squared. Add the 19 over. And this is vertex form. So what we're saying is this standard form will make a parabola. This vertex form will make the exact same parabola. Minus 2 minus 2. Perfect square trinomial. This one gets a little messy. Negative 1 divided by 2 is negative 1/2. Squared is 1/4. So we make this y minus 7/4 equals x minus 1/2 is how this thing factors. Add the 7/4 over. So again, this vertex form and this standard form make the same parabola. Solving the system. Now all of a sudden, for the rest of this test, decimals and those solutions are in play depending on how it falls out. So what I'm going to do is rewrite this one. Negative y equals negative 3x plus 5. Divide everything by negative 1 and get y equals 3x minus 5. Then I'm going to sub it in right here. So x squared minus 3x minus 3x minus 5 equals negative 6. X squared minus 6x plus 5 equals negative 6. X squared minus 6x plus 11 equals 0. Now I'm ready to start the quadratic formula. So negative b plus or minus the square root b squared minus 4a c all over 2a. So then our discriminant comes, let's see, 36. So negative 6 squared minus 4 is negative 8. By knowing that the discriminant right here is negative 8, I know that puts me in an imaginary land, and we don't mess with imaginary intersections and systems. So right there, I'm finished and can start doing that. This next one, I'm going to take this, sub it in for this y. So make it x squared plus x squared minus 3 plus 1 equals negative x squared. Add the x squared over, make it 2x squared minus 2 equals 0. I'm personally going to factor. It lets me avoid a lot of headache with the quadratic formula. This is, of course, the difference of two squares, which now must mean x equals 1 and x equals negative 1, which then means we will have two coordinate pairs. One will be 1 comma, one will be negative 1 comma. If I put 1 into this x squared, 1 squared minus 3 is negative 2. If I put the negative 1 in there, of course with parentheses around it for the calculator, it will also be negative 2. You can learn about this next one a bunch of different ways. I'm going to write this as x. I'm going to keep it as, I'm going to write it as, let's see, negative y equals negative x minus 1. Divide everything by negative 1 and have that. Then I'm going to take this, sub it into that y. Then I'm going to go x squared plus 2x plus 1 equals 13. 2x squared plus 2x minus 12 equals 0. Looks like I'm doing a quadratic formula of this bad boy, so negative b plus or minus b squared minus 4a c all over 2a. Change color because we're running out of room. Negative 2 plus or minus, let's see, 2 squared minus 4 times 2 times negative 12 is 100 divided by 4. So negative 2 plus 10 divided by 4. I got one answer to be 2, and negative 2 minus 10 divided by 4, I got negative 4.5. So if I plug in 2, comma, and negative 4.5, comma, I got to plug them back in. I'm going to plug them in right here. So 2 is 3, and negative 4.5 is negative 3.5. Yeah, while I'm at it, I'm going to hurry up and grab something.
We had the same song last week.
Let's see. Negative 2 minus 10 divided by 4. Negative 2 plus 10. Oh, okay. Well, this was really silly of me. That's why I went and grabbed and checked. Also, why I don't always like the quadratic formula. I think this should have been 2, and then negative 2 minus 10 was going to be negative 12 divided by 4 is negative 3. And then when I plug negative 3 back in there, I think I get negative 2. Sorry. Okay, this next one was actually the exact same problems we had seen on a review, seen on a quiz. Here's the things I look at. I see this must be a solid line. I see this must be a parabola that opens down. I see this as a y-intercept of negative 3. So y-intercept negative 3 in solid line opening down, negative 3 solid line opening down. So now I got to look at greater than or equal to. So the way I tried to picture this was greater than the vertex, and of course this shading is greater than the vertex, so that's C. This right here, dashed line, opening up, positive 3. Positive 3 dash line, and that's it. So now we're done with C and we're done with E. I see solid line, opening down, negative 3. Solid line, opening down, negative 3. For good measure, that's less than the vertex, less than the vertex. I see dotted line, opening down, vertex, or intercept at negative 3. Dotted line, negative 3. And that's the only one that's even opening down or meets these two. But if we're going greater than, it's greater than the vertex. Opens up, a solid line, y-intercept at negative 3. Opens up, negative 3, solid line. I think this might be the only one that fits anyway, but we can go less than the vertex if we want to for the shading to get there. And of course, we're left with D, but dash line opening up, negative 3 y-intercept. Again, I think you had those on a previous quiz verbatim. All right, starting here. So let's start with solving this thing rather standardly. Let's start by making the thing equal to 0. Well, greater than or equal to 0. Great or, which means, and with this type of sign, I'm either going to be x is less than a number or x is greater than a number. It's just a matter of what numbers those are. So negative 11 plus or minus square root of b squared minus 4ac over 2a. Negative 11, well, 11 squared minus 4ac. So make it a negative 11 plus or minus the square root of 169 over 4. Square root of 169 is 13. So then we have negative 11 plus or minus 13 over 4, which then means negative 11 plus 13 divided by 4 is 0.5. Negative 11 minus 13 divided by 4 is negative 6. So I'll put the smaller number here. We can be less than negative 6 or greater than 0.5. I'm going to get this next one equal to 0. Again, this is a great or sign, great or. So I know that it's going to be this or this. And all I got to do is fill in the numbers. So negative b plus or minus square root of b squared minus 4ac all over 2a. So to simplify, negative 3 plus or minus square root of 13 over 1. So negative 3 plus the square root of 13. Again, we can use decimals here. We talked about that at the beginning of the page. Negative 3 minus the square root of 13, and we get. So I put this here and this here. We also have another video on how to do these that you can go back and look at, or you can come see me anytime. First thing I want you to notice that the orientation has changed. It's now a less than sign, which means it's going to be this style. So now negative b plus or minus b squared minus 4ac all over 2a. 5 plus or minus, what's this discriminant? 9 over 4, so 5 plus or minus 3 over 4, which means I got 2 and 1/2 or 0.5 depending. Again, if you're having issues on these, this was a very minor part of this chapter, but ended up being a big enough point total if you didn't know what you were doing. One last page. Okay. A rectangular pool. We got water in there. We're swimming laps. That's 10 by 5. Want to build a deck around it. Seems like a perfectly reasonable thing to do. We don't know the width of the deck, so we'll use a variable there. So that takes care of that. Uniform width. Now, all the way around, total area of pool and deck together is 126, which means this by this needs to equal 126, which means 10 plus x plus x, 10 plus 2x, 5 plus x plus x, 5 plus 2x has to equal 126. So I'm going to do this. Which means if I Punnett square that thing out, I'm going to get 50 plus 10x plus 20x plus 4x squared. So that's 4x squared plus 30x plus 50 equals 126. Before I can ever start solving, I got to subtract the 1x squared, or the 126 over. So 50 minus 126 is negative 76. I have a feeling this is factorable, but I don't want to take the time to find it, so I'm going to go to the quadratic formula. So I'm there. I go have negative 30 plus or minus. Let's see what that discriminant is. 30 squared minus 4 times 4 times negative 76. Let's see if we can square root that thing straight away, which we can. So negative 30 plus or minus 46 over 60, which then means 30 plus 46 divided by 60. Did I screw something up? Hold on a second. Oh, silly. It's all over. I was going to say, because I ain't falling out with it. All over 2a, which means it's over 8. So negative 30 plus 46 divided by 8 is 2. Negative 30 minus 46 divided by 2, or divided by negative 76 divided by 8 is negative 9.5. So this is extraneous because you can't have a negative width. That's the width of our deck, which is all that we were asked now. Some of you went ahead and found dimensions too, and that would have been 14 foot by 9 foot. A couple more. A review of a revenue problem. I thought this was going to be a gimme, but it wasn't for a lot of you. Price $11, but we're thinking about increasing it in $1 increments. We don't know how many, so we throw an X there. We did sell to 400 people, but we lose 20 people, decrease every time we increase the price. We don't know how many times that's going to happen. Multiply it out, we get negative 20x squared. Plus 180x. I'll let you verify that for yourself. Plus 400 or 4,400. Now, when it says maximize, it's telling us to find the vertex. So I'm going negative b over 2a, which is negative 180 over negative 40, which is negative 180 divided by negative 40 is 4.5. So I now know the x coordinate is 4.5. Take that 4.5, plug it back into my original equation. And I'll get, so if I take this and plug it in for that x and that x, what I got back was 4805. So now the point of my other two boxes is that you need to recognize that that y coordinate of the vertex is the max height, which means the max revenue. Now this 4.5 is an x. If we want the new ticket price, we got to put 4.5 in there. And when we do, we get 1550. All right. This was kind of similar to our last quiz where I put a stretch problem on there that we hadn't quite perfectly gone over. There was one just like this on the review sheet we had taken, but let's go ahead and see. So t is seconds. How high is the ball after 1 second? So if we plug in 1, we get 20.6 meters. It's in meters. Find the maximum height of the ball to 1 decimal place. So I'm going to go negative b over 2a and get negative 24.5 divided by I'm going to get 2.5 seconds so I'm basically finding the vertex. Anytime I see the word max, I'm thinking vertex. So I got 2.5 comma. I'll run it back into this equation. So negative 4.9, 2.5 squared plus 24.5 plus 2.5 plus 1. You get 31.625, but it says to one decimal place, so 31.6. So the maximum height is 31.6 meters. When? This is the when. So 2.5 seconds. When does the ball hit the ground, which is telling us find the zeros? The ball is traveling something like this. So once you find this x-intercept, so I'm going to set this equation equal to 0, and I'm going to solve. So I'm going to go negative b plus or minus square root of b squared minus 4a c all over 2a. Let's see, negative 24.5. Simplify the discriminant. Still going. Let's see, negative second square root of 619.85. So if I go negative 24.5 minus that divided by, I get an x equals 5.04. If I go negative 24.5 plus, I guess something like a negative 0.04, which is an extraneous, can't have a negative second. So this must be 5.04 seconds. Okay, maybe my favorite problem on the whole test was the bonus. Let's see. The sheet of cardboard is 10 by 12. We want to cut out equal size parts of the corner. Right? And it's going to be a square, so we don't know how big, but it's x by x by x by x by x by x by x. Now, if you imagine a net being folded up, which you have done before in different grades, like this thing being a net, you will understand that there would be the base of the box, and we want this to be 80 inches. So what's the real dimensions from here to here? I'm saying it's 10 minus 2x. It's shorter than 10, right? 12 minus 2x. So what we do is something like 10 minus 2x, 12 minus 2x equals 80. Multiply that whole bad boy out. You end up with something like 4x squared minus 44x plus 120 equals 80. Can't do any of our solving methods until we get it equal to 0. I think I can actually factor this, right? So I go x minus 10, x minus 1 equals 0. X equals 10, x equals 1. Now, the one reason that this has to be extraneous is because we can't have this be 10 and this be 10 and then the whole side be 10. It just wouldn't make sense. So our bonus answer was x equals 1. And that was your test. It was a tough one. I think you had the ability to do it. Now we're just going to have to fight back.